Yes, sir.
Farhan, what about you, Farhan? You also have Windows. Yes. Yes, Farhan. Do you have Windows, Linux, iOS? What do you have?
No, no, sir, I don't have.
Oh, so how did you join this class? So from which device you are joining?
Sir, I am using mobile.
Mobile. Okay,
Yes, sir.
so you have your laptop in your house, right? So can you get the laptop because today we will need some system, right? So desktop would be also okay, but if it is a laptop, that would be really helpful, right? So because we are going to study simulations, and in simulation you can't do simulation in mobiles, right? So yeah, please can you arrange some laptops
Sir, today I can't get it, sir.
today? Oh, okay. So that thing I have already told you guys because in the last class, what you did in the last class? Were you there? So that class was 2 weeks before, right? In the previous week, we didn't have any class, but the week before the previous week, right? In that one, I told all of you guys to just bring your laptops and specifically the Windows operating system, right? Okay, so yeah, you can just see, but these two people, Elena and Alan, they can just install and they can run those programs, right? So as you can see that with Universe Sandbox, right, you can simulate gravity. So gravity is, what is gravity? Yes, guys,
Force
that
of
thing.
attraction.
Yeah, so gravity is force of attraction, right? Whenever two objects which have masses, so they can interact with this gravitational force, right? So gravity is one of the four forces that we have in nature, and that governs, yeah, so that governs nature. And from gravity, you can have planetary motions due to gravity. You have day and nights due to gravity. There are several implications of gravity, right? The structures are due to gravity. So there are several implications. The light that you see, oh, that is because of the nuclear fusion. But yeah, so gravity has so many different implications, right? So in this simulation, we will learn about how we can simulate gravity between different systems. So those gravity can be between sun and earth, right? And between different planets as well. And then between the planets and the moons, right? So we can simulate gravity with this universe sandbox. And then we can also collide different planets and stars. And then we can see what happens because due to collision of different stars or due to the collision of different things, we have supernova, and that gives that emits a very high amount of energies, and those energy we can observe to find out different properties of the universe, right? So this we can do, and then we can also create our own planetary systems, right? We can also create our own solar system, and then you will be able to see that how we can do that, right? So these are the simulation, and then we can also model Earth in different climates and how it can grow to the Earth that we can see now. So there are different simulation, and then the supernova and stuff, right? So all these things we can do with this simulation, right? So this is the introduction of the simulation. I'm going to send you the file that you have to download, and then and then we can just learn about the simulation, right? So let us see what we can do with that simulation, right? With this beautiful yeah. So this is our Earth, right? Let me just stop this thing, and then these are the different planetary systems, right? And these are two galaxies, and how they merge together, and then they form another galaxies, and then these are the different planets that you can collide, and then you can see that what can happen, right? So this is a very beautiful simulation to understand some aspects of physics. And this would be really helpful in understanding some aspects of physics, right? So yeah, let's just download this thing and then we can learn about this thing, right? Okay. So before we do that, right, we have to already, because you guys already know what is gravity, then what is orbital motion, circular motion, right? And in circular motion, what are the crucial aspects of circular motion? Yes. What can you guys tell me about circular motion?
So the direction changes continuously.
Yes, its direction is.
Changing continuously.
Yeah, so it's because you have velocity in a circular motion, so its direction is always changing, right? Because it is changing tangentially. Yeah, so that one is a good answer. But what becomes equivalent in circular motion? What becomes equivalent?
So displacement.
Mm, Yeah, displacement becomes equivalent. Displacement. Displacement is yeah. So displacement is always changing, right? In circular motion. Let me just write this thing. Okay, so in circular motion, right? Let's say you have this central body, and then you have this thing which is circulate, right? Because circular motion is due to some force. And what is that force in planetary system? Circular motion is due to which force?
Gravitational.
Gravitational force, right? So your Fg is equal to this centripetal force, right? So your mv square r is equals to this gmm divided by r square, right? So that is what is called the orbital motion or circular motion. And then we can just cut these things out. And then this thing, this is what we call the orbital velocity, right? So this thing we have already studied. And this is simply, this is gm by r, right? So this is the orbital velocity, and then yeah, then we have this escape velocity as well. So all of you guys are in 11th or 12th, right? Or maybe in your 10th standard, but as of now, you guys have not studied about this. So all of you guys are in 11th and 12th standard, right?
So I'm in my
Oh, you are in 9th. So yeah, so you will yeah, so you will understand about the circular motion in higher classes, but just to understand, so there are one circular motion happens due to this gravitational force, and this gravitational force is providing this centripetal force, right? So in circular motion, there is always a force towards this center, and that force is called the centripetal force, right? And that is given by this gravitational force, right? So yeah, and that is why you have this orbital motion or circular motion. So this is what you have to understand. And one more thing, that there are some units that we will be talking about, right? So those would be astronomical units to measure the distance, light years that we have already discussed, and then parsec. So these are the measuring quantities that we will be using. And then what is the other thing that we will be using? Yeah, so this will be it, right? So this is the background to understand all these things, right? Now let me just send you the file, and then you can download. You can download that thing, and then you can just. Oh, so Ibrahim Mateen has also joined, right? So let me just send you guys. Where I can share that file. Share computer sound. Okay, so there's show meeting chat. Yeah, in chat box I can show you, right? Share file. That is in desktop. No. Yeah. Okay, transfer of exe file is restricted by your account admin. Okay. Yeah, then can I share the zip file? Transfer of file larger than 1 GB is restricted by your account admin. Okay. Why this is restricted? Oh yeah, so let me just ask the Learnivio team so that they can share. Because I cannot share this thing. I can also not actually transfer of military file restricted by. Just let me just talk to the. Right. In the meanwhile, just I will just open that simulation that you guys will be given. Right. In the meanwhile, let me just talk to the learning team. Yes, can you guys hear the background sound?
Yes, sir.
Okay, so I have texted them, but they are not replying. Let me just mute this thing, right? But this would be really cool to hear those sounds. But this is really nice, right? Okay, why they are not replying? Okay, so I will send you guys this thing, but let us just, yeah, so I will send this thing because they are not picking up or they are not replying. So, yeah, I will share this thing in your Google Meet, right? So I can just share this in Google Drive, and then from Google Drive you can download it, right? Because the file is 1 GB, so it will take some time to download, and then you can just play with this simulation, right? So firstly, let us understand about the simulation, and where I can just, yeah, so master volume not 100%. Yeah, then this would be music volume 20, and then we can just, yeah. So this is, now this is not noisy, right? Okay. Yeah, so let's zoom this thing in, right? And then in planetary system, usually what do we see? So usually we have planets and sun. So are there any things besides planets and sun? Are there anything else beside planets and yes?
So asteroids.
Asteroids, yes, correct, absolutely correct. So there are asteroids other than planets and sun. Any other thing? Good.
Sir, dwarf
Meteorites.
stars.
Meteors, yeah, meteors, dwarf stars. So in planetary system, there are no dwarf stars, right? So they are outside that planetary system. There is one very crucial thing, right? Meteors, asteroids, they are there, but there is one very important, because you can see,
Black hole.
yes,
Black hole.
black hole. I'm only talking about a planetary system, not,
Sir, dwarf planet. Pluto.
yes, dwarf planet are there. Yes, absolutely correct. So only in the solar system I'm talking about, right? Not in the galaxy. In the galaxies, we can have several supernovas, different stars, and yeah, so dwarf stars, all the other things we can have. But in planetary system, we have asteroids, we have meteoroids, and we have these small planets. And then what are the other? So very important thing,
Moon.
moon, right? So we have moons. Moons of different planets. So they make up the different planetary systems, right? So you can see that there are various orbits. So there are planets, but we also have these small dots, right? So what is this thing? This is what? This is asteroid orbiting sun, right? So first, let us understand what are the parameters of Earth, right? So we have, okay, just catch this thing. Yeah. So we have Earth, and all the other things we are measuring in with respect to Earth. So that is why you see 1 m Earth, right? The mass is equal to 1 mass of the Earth, and the radius is equal to 1 radius Earth. So that is the basis quantity, fundamental quantity, and with respect to this thing, we are measuring all the other things, right? And then, yeah, so this is what is this quantity? Can you guys tell me what is this quantity?
Sir, what quantity?
Third one. So first one talks about the mass of Earth. Second one talks about the radius of the Earth.
The density.
Density, right? So this is this one is the density, right? And they have not shown in SI units, right? So this is in CGS units. And yeah, the fourth parameter to define a planet is the temperature. And then the last one is the speed, orbital speed, right? So this is orbiting the sun with this much of velocity, right? And due to this velocity, what do we have? Yeah, due to the velocity of Earth around the Sun, what do we have?
Sir,
Yes.
so
We
orbit.
have, yeah, we have this orbit, right? So we have these 1 year, right? 365 days due to the orbiting of this Earth around the Sun, right? And
Yes.
then we have day and nights because of what? Yes. Why do we have day and nights? Can anybody tell me? Why do we have day and nights? Because that is again due to rotational motion. What is rotating? Yes. In here you see that the Earth is orbiting around the Sun, and for that we have these calendars, right? 1 year calendar. We have these months and all those years, 365 days. But we have day and nights also. And what makes those day and nights? Why do we have day and nights on Earth?
It's a rotation of the Earth.
Rotation of the Earth, right? Because the Earth is also rotating on its own axis, right? So that is why we have these day and nights. Good. Yes. Okay, so I guess the learning is responding. Yes. Okay, whenever they just allow me to send this file, then I will send this file, right? So this is the basis with which all the other planets, all the other things would be defined, right? And you can see that this planet, so this planetary system is overly crowded with the moons and the asteroids. And we are lucky enough that these asteroids are not colliding on Earth, right? Because whenever they collide, then we are doomed. So due to these peculiar velocity, these orbital velocity and these gravitation, we are saved. So let us understand about the other planets, right? So let's take an example of the closest planet, and that is Mercury, right? Okay. Yeah, just catch this thing. Yeah. So you can see that the mass of Mercury with respect to Earth. So this M Earth meaning the mass of the Earth. So you can see that the mass of Mercury is pretty small. That is 0.05. And how much is 0.05? It is 0.05. Yes, how much is 0.05? 0.05, you just divide it by this thing. So 1/20th of the mass of the Earth. Right. So this is 20 times smaller than the mass of the Earth. Right. And then what is the size? So we can see that the size is also pretty small. And we can see from here also. Right. So this is 0.3 times the size of the Earth, which is 1/3. Right. So 1/3 the size of the Earth and 1/28 the size of the Earth. So all the quantities that we are, all the planets, all the asteroids, all the moons that we are measuring, that is with respect to the mass of Earth. Let's take the biggest planet. What is the biggest planet? Can you guys tell me?
Jupiter.
Yes, Jupiter. Right. So let's check. Let's check what is the size of the Jupiter and what is the mass of the Jupiter, right? So let me just stop this thing. Why this is. Where is that recent?
They're at the left corner.
No, so yeah, I know that, but where is that reset thing? This has started rotating. It's yeah, that reset thing in here. No, so the reset one is in there, right? Here. So this one is the reset, right? Okay, so let's see where is Jupiter. Right, this one is the Jupiter, right? And you can see that the orbit of Jupiter is pretty large, right? So these is Jupiter, so this has a very large orbital distance, right? And then we have Saturn, and yeah, what is this? 1995 SN55. And the largest one is this Pluto, right? So this one has the largest distance. So this one is the farthest one, and the Mercury is the closest one. So let's see the mass and size of the Jupiter, right? Oh, this is our Sun, right? Yeah. Oh, so they have not written in terms of, okay, so they have not written in terms of right? Because let's see. Oh, so whichever one is the larger one, they are writing that one, right? Because Jupiter one, they have not, they're writing as one mass of Jupiter, right? And let's see Venus. So Venus, they have written in terms of Earth, right? Let's check Mars. So Mars is also written in terms of Earth, and the other one. What about Pluto? Let's check Uranus. So Uranus also, yeah, they have also written in terms of Earth. But why Jupiter? Jupiter is not written in terms of. Yeah. So you can see different aspects of this thing, right? Jupiter. And we can also see the mass in here in terms of Earth, right? So we can check from, right? And then in terms of Earth, we can also, so many things you can do with this simulation, right? And yeah, so we see that this is 318 times the mass of the Earth, right? And what about Uranus? So we also saw that Uranus is also massive than Earth, and it is also bigger than the Earth, right? But because it is farthest from Sun, so the temperature should be higher or lower. What about the temperature?
Lower.
Lower, right? So you can see that the average temperature is minus 221 degrees C, right? So you only have ice on Uranus if there are water, right? So do we have water on Uranus? Composition we can check, right? So iron is 4.67%, right? And do we have water? Okay, so we have 74.7% water, right? Which means that all of this would be in which form? What would be the form of the water? Can you guys tell me?
Gaseous.
Gaseous. What is the temperature of Uranus?
Minus 221.
So will there be gases at minus 221? So you have water. Gaseous means vapors, right? At minus 221 degrees C, will you have vapors or will you have ice? What will you have?
So we have gases like methane gas is there.
I'm talking about water, right? I'm talking about water,
No, sir.
right? So what would be the form of water on Uranus? That is the question.
Solid.
Solid, right? You can see from here. And why this would be solid?
Because of the temperature.
Temperature, right? So we can connect all those different informations, right? Because the temperature is minus 22, 21 degrees centigrade, and the water freezes at 0 degrees C, right? So then the form of the water would be solid, or yeah. So that would be ice. So that is what about we know about Uranus, and then we can see the other things as well, right? So let's say this 2014 NW65. What is this thing? Can you guys tell me what is this
An
thing? I also
asteroid.
don't know. This is an asteroid. Yeah, so this is certainly not a moon, right? So this would be an asteroid orbiting Sun, right? And you can see that the mass is how much? Is this thing a smaller quantity or is this thing a larger quantity?
Smaller quantity.
And what does this E signifies? What do we mean by this E?
So power.
Power, absolute. So you are in ninth standard. How do you know all these things, right? Good. Yeah, so this means power, right? So 3.7 into 10 to the power minus 0.06. So the power is 10 to the power minus 6, right? So that is a very small quantity. And you can see that this is 116 kilometer, right? So maybe the size of some state, right? So yeah, this size is very small and the mass also also small, and the density is higher, right? Because what was the density of Earth? The density of the Earth was, so this was 5.51 gram, but the density of this asteroid, oh, yeah, so the density of this asteroid, which was NW 2014,
3.46.
3.46 or 9 something, right? It was that. Where did that go? Yeah, so this is 3.49, right? So the density is nearly the same as the Earth. But the temperature is again minus 214 degrees centigrade. So yeah, there are various information that we can get, and then you can just click on this thing, and then you can see the compositions, right? Oh, so here they are, yeah. Okay, now we have different things, right? Here they are telling that this is 3.77 10 to the power minus 7, the mass of the O. So what is this quantity? Can you guys tell me?
3.77 into 10 raised to the power minus 7.
Minus 7. But we saw that the mass was 3 point something into 10 to the power minus 6. What is this mass that they are telling?
So
Yes, think about it. Only Arhan is replying, and he is in 9th standard, guys. Yes, rest of you guys. So one guy left, Mateen left, right? Alina and Farhan, what about you guys? What is this mass?
Sir, it is the mass of iron present in the earth.
Yeah, not in the earth, not on the earth, but on this asteroid, right? 2014 NW65. So the iron content of that asteroid, right? And then, yeah, so you can check the silicate, water, and all the other things, right? But yeah, so let us see what are the main composition of our Earth, right? So we can also check that because we can do various thing from this simulation, right? So there are infinitely many things that we can do. We can learn from this simulation, but yeah, let us check what are the compositions that we have, right? So we have iron that is 24.7%, right? We have silicate that is 75.2%, and water 0.0239, and what is this thing? Hydrogen is this much. So, okay. Iron is 24.7%. Generally, we have 70% water and then, yeah, so, and then 20% of nitrogen and gases, right? So that is the main composition of the earth. But here we see that the iron content of the earth is 24.7 and silicate is 75%. So the major component of the earth, we're talking about the earth, right? So that is silicate, right? And water is 0.0239%. So this thing is about, I guess, the core, right? So
Yes,
all
sir.
these that you are seeing, that is about the core of our planet Earth. Because our Earth is made up of 70% nitrogen and then we have the other gases, right? So that is the composition of the Earth. And this composition is about the cores, right? Okay, and then surface, yeah. So level, surface level, yeah, minimum temperature is -67, maximum temperature is 20.2. But nowadays the maximum temperature is what? So you can see that this is the distribution of the temperature, right? And yeah, these are some hot patches. So you can see that, yeah, these are very high temperatures, right? Okay, and then what are the other things that we have? Motion, right? Okay, so distance is 0.97 for AU and speed is 30. So, okay, 29.5 or 6, that is the orbital or the circular velocity of this thing, the rotational velocity of the Earth itself, not the orbital velocity, right? And orbital period is 12 now. That we already know, right? Okay, so this is about, oh, what is happening? Yeah, so these are the things that we have. And then what are the simulations that we can have, right? So we talked about that we can simulate gravity, we can simulate temperatures, we can simulate the collisions and all those things we can simulate, right? So all those things we can do. And we will also learn about that thing in the next class also, right? So Ibrahim Mateen has also joined. And you guys can also play with this simulation, right? I will send you guys the extension file, right? The exe file, and then you can download that thing, right? Okay. So there are, what about the moons, right? You can see the clusters of the moons in here, right? So, for example, let's say, why this is not zooming? Yeah. For example, which one has the highest amount of moons? Do you guys remember?
So Saturn.
Saturn. Okay, so let's check Saturn. Where is Saturn? Where is Saturn? So this is Mercury, right? M, Jasola. Earth, Mars. After Mars, we get Saturn, right? After Jupiter, we have. Yeah, so this one is the Saturn. And how many moons does this thing have? Have they written about the moons? They have obviously they should write about the moons, right? There must be the number of moons somewhere in here, right? People. So speed is rotational period. Distance to you, orbital period 29.4 year. Okay, so you can see that how much time it takes to have 1 year or one orbital period, 29.5. And we have 12 months, right? So our orbital period is 12 months. This one has 29.5 years, right? So, okay. And the age is 4.6 giga year. How much is giga years? What is giga? Can anybody tell me how much is giga?
Is that a billion?
A billion, yes, absolutely correct. So giga is 10 to the power 9, right? Good. Okay, but where do we have the number of moons? Radius from composition, density nodes, uh, add moons to the planet. We can add, but we have to see how many number of moons do we have. Okay, there must be somewhere in here. I don't. Okay, there must be multiple data views, right? If I do that, what will happen? Okay, so this is temperature. Motion, surface, not action. Okay, so the number of moons would be somewhere here, but I cannot find it. We'll check that later, right? We'll check that later, but yeah, you can see that these are, so this is ice. This is an asteroid, Pneumonia. This is an asteroid, Vesta. Asteroid, oh, we have so many asteroids, right? So there are lots of asteroids. Where are the moons? Let me just okay, so view orbits we have, right? And then habitable region, and then yes, we surely should have moons, right? Let's check. Yeah, so we have this Earth. Okay, they have not shown the moons, right? Because we cannot see the moons around the Earth. So they are only showing the asteroids, right? And different planets and the sun. We don't have any moons. So maybe we will have those moons, but we have to put it with this simulation, right? So what are the simulations that we can have? Let's check that. This is yeah, so there is a tutorial in here, and we can start with this beginning, right? So yes, welcome to Universe Sandbox, and the first thing that we can do is, yeah, this one we have already seen, right? So let's aim at the Earth and click to launch series, right? So what is this? Let's launch this thing in here, right? And why this one collided?
Due to the gravity of the Earth.
Yeah, because of the gravity. And what was the thing that we didn't provide? So
An
we have
axis.
to, yeah, we have to provide the velocity in such a way that it matches with the orbital velocity, right? So that is the thing that we have to apply. So we know the mass of Ceres, right? And we know the mass of the Earth, and we know the radius or the distance between them, so that we can calculate the orbital velocity, and that much velocity that we have to provide, right? So let's say I put it in here, right? So then this will go slowly, right? Just so this is going slowly, right? And this one is but there are other ways we can destroy Earth too. So this is some destructive classes, right? So let's say that, yeah. So click tools. You have to just click tools, and then this add one, and then we have so many things to add, right? So these are moons, and then you have these planets, and then you have these asteroids, or what are these minor things, right? And then you can also project the galaxies, but we cannot project galaxies inside the planetary system, right? So what we can project moons, right? Let's select one moon. So what is the moon that we should project, right? How much time? Oh, we already extended the time. Okay, so in the next class, what I will do is that I will send this simulation to you guys, and then you guys can play with it, right? So we'll learn about this tutorial in the next class also. But did you find this thing fascinating, amazing? So did you enjoy this thing, the simulation,
Yes, sir.
guys? Good. So I will send you guys the simulation, and then you can just play with it, right? So let's say that, what is this thing? This was the moon, right? And then let's say Titan. So this Titan is the moon of what planet? Yes. This is the moon of which planet?
Jupiter.
Jupiter, right? Yeah. So this is Titan, and then we can, Io is also the moon of Jupiter, I guess, right? And then yeah, Titania, Triton, Leptus, and so many things we can do, right? So there are various things that we can do with this thing. And okay, so we have to just pick another look. Let's put this thing in there. Let's put so many moons. And then you can see that if we provide so many, so the gravitational force would be so large that it will attract, and then this moon would be destroyed, right? So, and it will collapse on this thing. So you can appreciate the beauty of gravity or the nature, because in nature you can see that how balanced are those things, right? They are perfectly balanced in such a way that the moon is perfectly rotating our earth, right? Otherwise, if we miss 1 meter here and there, then it will collide on earth, right? So that is the beauty of nature, that everything is precisely perfect, right? That is perfect. Okay, so we'll talk about this simulation in the next class also, right? So yeah, we'll stop here and